I'm going to do several problems from 7.4 in pairs, just so the videos don't get too long. The first one, I'm going to do 13 and 21 together. So the first one here, 13, says secant of x plus tangent of x equals 1. So we're going to find the solutions. And one of the big recommendations when you're doing something like this is to convert everything to sine and cosine. It's sometimes a lot easier to see it that way. So I would call this 1 over cosine theta, or x, plus sine of x over cosine of x equals 1. And so what we have is 1 plus sine of x all over cosine of x equals 1. Now, we're not going to get out of this without a little bit of, work to go on. I was going to make an analogy, but I think nothing works except it's going to be work. So I'm going to clear the fraction by multiplying by cosine of x on both sides. And we end up with 1 plus sine of x equals cosine of x. Now here's where it's going to get uncomfortable for some people. Recall that sine squared x plus cosine squared x equals 1, Pythagorean identity. And if we solve for cosine squared x, we'd have cosine squared x equals 1 minus sine squared x, or cosine of x is the square root of 1 minus sine squared x. And this is the relationship we're going to use, and we're going to substitute this expression in here so that we end up having 1 plus sine x equals the square root of 1 minus sine squared x. I forgot my x there. Okay. Now this is again where we're going to get uncomfortable, and we're actually going to do something that causes the potential introduction of an extraneous solution. We're going to square both sides. So if you recall from your Math 126 days, you have to watch out for extraneous solutions. And this becomes 1 plus 2 sine x plus sine squared x equals 1 minus sine squared x. And if we bring everything over, I can subtract the 1 from both sides. I can add the sine squared x to both sides. And we end up with 2 sine x plus 2 sine squared x equals 0. From this, I can factor out 2 sine x, and I'd have 1 plus sine x equals 0. So by the zero product property, 2 sine x can be set equal to 0. And 1 plus sine x can be set equal to 0. And we solve each of these independently. And divide by 2, sine of x equals 0. So we're looking at x being 0. Works for that. Now, they're asking for all the solutions. So if this works, we'll also consider adding the 2 pi n or 2n pi. I've seen it different ways. But that generates all those values at 0, 2 pi, 4 pi, 6 pi, negative 2 pi, negative 4 pi, and so on. Then with the other side, we subtract the 1. Sine x equals 3 pi over 2. Oh, nope, I'm jumping ahead. It's not good when you know the answers. Sorry. So, yeah, let's stick with this. X equals 3 pi over 2, I just said. Now, again, we'll add that generator for the other values if need be. But it's important because we squared both sides, we've introduced potential extraneous solutions. So we're going to go back to the original that said secant x plus tangent x equals 1. So if I look at secant of 0 plus tangent of 0, is that 1? Is 1 plus 0 equal to 1? And yes, it is. On the other hand, secant of 3 pi over 2 plus tangent of 3 pi over 2, is that equal to 1? Well, secant of 3 pi over 2 is undefined. Tangent of 3 pi over 2 is undefined. So this doesn't work. So x equals 3 pi over 2 is extraneous. So our solution is x equals 0 plus 2 pi n, or 2n pi. Or we could just say that's going to be 2 pi n, or 2n pi. Okay, the other one that we had that was asked, I have a whole set I'm working on, but I'm going through them, like I said, 2 at a time, so the videos don't get too long. We have number 21, 2 sine squared x plus 7 sine x equals 4. Now in this one, they want the solutions to be in the interval from 0 to 2 pi, not inclusive of the 2 pi. Maybe it was inclusive. It's not inclusive, okay. So what I find easiest to do here, well, I'll do the first little step, subtract the 4, and get everything over to one side. So it's 2 sine squared x plus 7 sine x minus 4 equals 0. And you might see it right now, and that's great if you do. This obviously is combining these skills we developed in algebra and pre-calculus with the trigonometric knowledge we have now. But one way to help see this better is to make a u substitution. And what I often make, well, for this case, I do u equals sine x. And in mathematics, u is a common variable we use for substituting expressions. So we have 2 u squared plus 7u minus 4 equals 0. And that would factor to be 2u and a u. Let's see, it's going to be a plus 4 here and a minus 1 is what I come up with. Looks like that's going to work. So I'd have 2u minus 1 equals 0, u plus 4 equals 0. So I'm using the zero product property. I can set each factor equal to 0. 2u equals 1, u equals 1/2, u plus 4 equals 0, u equals negative 4. Okay, so what was u? U was sine of x. So I take that sine of x now and I put it in place of the u. Sine of x equals 1/2, and sine of x equals negative 4. So for what values from 0 to 2 pi does x make sine of x 1/2? Well, that's when x is going to be pi over 6. And 5 pi over 6. What makes x? What value of x makes sine of x negative 4? Nothing. So there's no solution there. So your solutions are these two here. Okay, I hope that helps.